GCSE question of the week, week 19, and the foundation higher tier overlap questions first. Number 1, a copper pole has a mass of 13.8 kilograms. The density of copper, so we've got a mass in kilograms, we've got a density in grams per cubic centimetre. The density of copper is 8.96 grams per cubic centimetre. Work out the volume. Okay, so you should be thinking already, right, this is to do with mass, density and volume. We need to know the equation, the formula. And the density formula is density equals mass divided by volume. Or if you prefer the triangle, we need the density here, and the mass here, and the volume here. Okay, so you need some sort of mnemonic to remember that formula. Ask me if you need some suggestions, but you need to know it. Work out the volume of the copper pole. So what do? We can either rearrange this equation to dV equals m, and then volume equals m over d, or if you're using the triangle, we can cover up the v, and we'll get v equals the mass divided by the density. So we've got to get that right for a start. We need to know, for a volume, we're going to do the mass divided by the density. Alright, so we could think, right, wow, we're sorted. We're going to put the volume is equal to mass, and the mass, that's this number, is 13.8 kilograms divided by the density, and the density is 8.96 grams per centimetre cubed. Alright, so here we've got a problem. This is in kilograms, this is in grams per centimetre cubed, so we're not allowed to do this. We need to convert one of them first, and it's going to be easier to convert the top one. Okay, so we're going to turn 13.8 kilograms into grams. Now how do we do that? Well, I know that 1 kilogram is equal to 1,000 grams. Therefore 13.8 kilograms, if I multiply by 1,000, that's going to give me 13800 grams. So 13.8 kilograms is the same as 13,800 grams. Now we can try again. We want volume equals 13,800, that was grams, divided by 8.96 grams. We're good. Grams, all good. Grams per cubic centimetre. Okay. Right, so what do I want to do? 13,800 divided by 8, not 88, 8.96. That gives me 1540, 1540 point, let's call it 0.18 to 2 decimal places. So 0.18. What's that going to be in? That's going to be in centimetres cubed. Our grams will cancel out. We've got a volume. Cubic centimetres, makes sense. Okay, nearly there. Give your answer to 3 significant figures. Okay, so this is not 3 decimal places, this is 3 significant figures. Alright, so we need to think. The first digit significant, it's not a 0. The second one significant, the third one significant. That makes this my decider. And my decider is 0. It's not 5 or greater, so we're not going to round that 4 up. That's going to give me V equals 154, which will leave us 4. Okay, now that's 3 figures, but I can't just not put another one because 154 is nowhere near the same size as 1,540. So this is a bit of an odd one, 3 significant figures here, because we're going to need to add that 0 as a placeholder. Okay, so volume is 1,540 cubic centimetres. Alright, that's a little bit of a trick that it says 3, well, it's not a trick. 3 significant figures here is a bit of a weird one. If it's 2 significant figures, we would have turned our answer into 1,500 cubic centimetres. If it had asked for 1 significant figure, okay, that would be this figure this one rounds our one up, we'd get 2,000 cubic centimetres. If it had said 4 significant figures, it's a bit weird as well, because we'd have to put 1540, would be the same as 3 significant figures. And if we'd have put 5 significant figures, we'd have got 1540.2. Okay, so we wanted this one. 1,540 cubic centimetres. Done. Number 2. A farmer grows wheat, barley and oats only. The ratio of wheat crops to barley crops is 3 to 5. Right, so we've got one ratio, it's 3 to 5, and the 3 to 5 is wheat to barley. The ratio of barley crops to oats is 2 to 7. Find the percentage of crops that are oats. Right, how do we go about this? Well, if I want to know the percentage of crops that are oats, I need to know something about how much is barley, how much is wheat, and how much is oats. But unfortunately, they're being mean and give me a ratio here that only includes 2 of those things, and a ratio here that only includes 2 of those things. So this is what I would suggest you do with questions like this. What we really want is to find out the ratio of wheat to barley to, what's the other one? Oats. Wheat to barley to oats. And we know the wheat to barley ratio is 3 to 5. And we know the barley to oats ratio is 2 to 7. So we've got 2 separate ratios, and I really want to combine them into one 3-part ratio. And the key to doing this is realising that if I could get this central number here the same, then I could lump together my 2 ratios. So how are we going to do that? We need to get a common multiple of that 5 and 2. So I'm thinking maybe 10. Okay, 2 times 5 will give us 10, 5's going to 10, 2's going to 10. So we're going to now multiply both ratios so that that middle number is 10. Let's just put the W to B to O again. Right, so what are we going to do? We want 10 here. We want to get this ratio, sorry, this number to 10. So looking at the 3 to 5 ratio, what did I do? Well, I multiplied the 5 by 2. So if I double the 3 as well to get 6, then the ratio 3 to 5 is the same as the ratio 6 to 10. Let's do the same thing here. I want to get this one to 10, because remember we're trying to get the same number in the middle. What did I do to get the 2 to 10? Well, I multiplied by 5. It's 5 times bigger. What should we do with 7? Times by 5. What's 7 times 5? 35. So all we're doing is changing both those ratios just by a constant multiplier to get that middle number the same. That's given me 6 to 10 to 35. Because now the central number is the same. I've got a ratio of 6 to 10. I've got a ratio of 10 to 35. I can just lump them together. 6 to 10 to 35. But we had to get that middle number the same. Right, how are we doing? Find the percentage of crops that are oats. Right, well, what is the oats bit? The oats bit is this. And how many parts of that ratio are oats? 35. And how much is that out of? What's the total number of parts? Well, that's 6 plus 10 plus 35. So the total number of parts is 51. So we've got 35 parts oats out of a total of 51. That's our fraction. We've got 35 51sts oats. Okay, now we need to turn that into a percentage. Okay, so to do that, let's get a decimal first. How are we going to get a decimal? Well, we're going to do what the 35 51st tells us. It tells us to do 35 divided by 51. And 35 divided by 51, thanks calculator, be quiet cat, gives me, as to D it, 0.686 blah 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 blah. So 0.68627. So we've got 0.68627 oats. How are we going to turn that into a percentage? Well, you need to know how to turn a decimal into a percentage. What do? We multiply it by 100. So 0.68627 times 100 is going to give me 68.627%. Right, give our answer to 2 decimal places. Right, not significant figures this time, 2 decimal places. So we need a 68 point, first decimal place, a second decimal place. Here's my decider. It's a 7, so we're going to get 68.6, and that 2 is going to round up to a 3%. 68.63% oats. Does that answer make sense? Yeah, I think so, because we had 35 parts out of, that's by far the biggest part, 35 out of 51, it's definitely over 50%, so around 2/3, sounds sensible. 68.63% oats. Done. Okay, number 3, find the reciprocal of 1.25. Right, now as I said earlier, this is easy. This is an easy mark as long as you know what the reciprocal means. And the reciprocal just means 1 divided by whatever the number is. So we want 1 divided by 1.25. That's it. That's all we've got to do. That's what the reciprocal means. 1 over the number. 1 divided by the number. Okay, so come on, Kalki. What do we got? We've got 1 divided by 1.25. That's literally all I've got to do. 4/5, 0.8. If you prefer, put it in as a fraction. 1 divided by 1.25. What do we get? Oh, it's 4/5. Oh, it's 0.8. That's my answer. Equals 0.8. Learn what it means. Right, number 4. A box has a mass of 5.6 kilograms to the nearest 0.1 kilogram. Write down the error interval. Right, it's another thing. We've got to know what it means. We've got to know what it looks like, how we write it. Error interval for the mass of the box, M. Okay, well, what an error interval means is we've measured 5.6 kilograms, but that's not precise. Okay, it could be a bit more than that. It could be a bit less than that. Okay, and it's telling me it's to the nearest 0.1 kilograms. Okay, that means that it could be half of that 0.1 kilograms bigger than this. It could be half of that 0.1 kilograms smaller than that. So one way to think about it is the 0.1 kilograms, if it could be half of that bigger, if we divide it by 2, we get 0.05 kilograms. So it's 0.05 kilograms either way of the 5.6. It's 5.6 kilograms plus 0.05 kilograms. That's the biggest it can be. Or it's 5.6 kilograms minus 0.05 kilograms. That's the smallest it can be. So what do those numbers give us? Well, 5.6 kilograms plus 0.05 kilograms, that's going to give me 5.65 kilograms. That's the biggest it could be. And this is going to give me 5.6 subtract 0.05 kilograms is going to give me 5.55 kilograms. That's the smallest it could be. So how do we write that as an error interval? Well, we write M, the mass, between these two numbers. And I start by thinking about, well, the mass is going to be less than 5.65 kilograms. So put the bigger number to the right. And mass is going to be greater than, or equal to, come back to that in a minute, the smaller number. We put the smaller number here, 5.55 kilograms. So this is our error interval. It says M is greater than or equal to 5.55 kilograms and less than 5.65 kilograms. So why have we got a less than, well, depends which way I read it. Why have we got a less than or equal to, or greater than or equal to here, and a less than with no equals on here? Well, this is about rounding. Right, if the mass actually was 5.55 kilograms, right, when we round it to one decimal place like we've got here, okay, then that's going to round up to 5.6 kilograms, which is what we want. But what if the mass actually was 5.65 kilograms, this number, which I said it could be earlier, but that's not quite true, because if it's 5.65 and we round it to the nearest 0.1 kilograms, that's going to turn to 5.7. And we know it can't be that, because we've measured it as 5.6. So it can't actually be equal to 5.65. It can be anything up to 5.65, but not including it, which is why we've got the mass is less than 5.565 or greater than or equal to 5.55. And your error intervals are always going to follow that format with this symbol here. and the symbol here.